Good morning and welcome to Mr. Thompson's Algebra 1 class. Today we're going to be talking about open sentences. Basically what an open sentence is this. It's an equation with a variable. And what we're going to be doing today is we're going to take various numbers and put them in place of that variable. It's basically what we're going to be doing today. Okay, so we got some terminology we have to cover. We're going to use a replacement set to solve an equation. So what in the world is all that? It's Chinese, really. But, so, at any rate, what's a set? A set is simply a collection of numbers. Example, what a set might look like. We have an example. We use braces to denote a set. Those are braces or squiggly things. We like to say squiggly things. An example might be the numbers 1, 2, and 3. That is a set of numbers. So we have a set there. A replacement set is the set of numbers that we're going to use to replace the variable with. So it is a set of numbers. A set. We know what that is now. To replace the variable with. And we've talked about what a variable is. We usually denote that with a letter of the alphabet. Okay, it represents some unknown value. That's what we're going to replace it. An example would be similar to that. But they're going to use something like the capital letter R. They'll say the replacement set is equal to the numbers -2, -1, and 0. Even though we're probably not going to be working with negative numbers yet. All right, a solution set then is the result of what we get after putting the replacement numbers in. So it is a set of numbers or number that makes the equation true. Okay, now we're going to do a couple examples quick. Example 1, we have an equation. An equation has an equal sign. We have a variable. Okay, like I said, an open sentence is basically an equation. And has a variable in it. We're going to evaluate it using this replacement set. We're going to put all the numbers and replace the letter A, which is our variable, with these numbers. So how we're going to do that, how you're going to show me how to do that. We probably won't do a ton of these problems because I know how much we all love making tables. Okay. So we're going to make a little table. A is my variable. And I'm going to replace A with each one of these. So I'm going to put a 3. We'll just start with 3. We'll start with 3 here. I'm going to put my equation here. 4A plus 7 equals 23. And then we're going to decide if that's true or false. So here we go, 4, replace it. We usually replace whenever we get substitution, this is called. We protect it with parentheses. So that really says 4 times 3, replacing A, plus 7. And I need to now evaluate that. Is that equal to 23? 4 times 3 is 12, plus 7 is 19. 19 does not equal 23, right? 19 does not equal 23. Therefore, we have a false statement. Okay? 4. We'll try 4. See if that works. See if that's a winner. Alright, so we got 4 times 4 is 16. 16 plus 7, 23. We got our winner. 23. Actually, sorry. Equals 23. That is true. Okay? Now, to save you some time, if we have an equation, I'm just going to let you know right now, there is only going to be one solution so far. Later on in the year, we will get ones that have more than one solution. However, we're dealing with linear equations here. We're going to have one solution. Once we find the true, it's really not necessary to use, we can put 5 and 6 here. And I'm not going to ask you to even fill that in. I'm just saying you can just say, well, that's going to be false and that's going to be false. And as far as work is concerned, that's great. The only other thing I want you to show me is what we call the solution set. What number or numbers from the replacement set make it true. The solution set equals, in this case, just the number 4. Okay. Let's do another quick example. Example 2. All right, we're going to use the equation 3 times 8 minus x equals, what do we got here? 6. And we'll use the same replacement set. How's that? So there's a replacement set. I need to make my table. I'm just going to put x here. And you got to worry about order of operations. Now we have parentheses. All right, true or false, T or F. I'm going to put my equation here. Okay, my replacement set, like I said, is going to be the same one. So I'm going to try number 3 first. 3, so we get 3 times 8 minus 3 equal to 6. So evaluate that. We need to evaluate that. We have to do what's in parentheses first. 8 minus 3 is 5. 3 times 5 is 15. That is not true. 15 does not equal 6. So I'm going to put false. Let's try 4. 3 times, that's ugly. 3 times 8 minus 4, that's 4. Does that equal 6? So 8 minus 4 is 4. 3 times 4 is 12. 12 does not equal 6. So that's false. Go ahead with 5. 3 times 8 minus 5, does that equal 6? Well, 8 minus 5, in parentheses first, is 3. 3 times 3 is 9. 9 does not equal 6. Therefore, we have another false statement. Oh, this last one's true. But we'll talk about what if it was. 8 minus 6 equals 6. So 8 minus 6 is 2. 3 times 2 is 6. 6 does equal 6. There's our winner. That's true. So I say solution set equals the number 6. Okay? Like I said, what happens if they're all false? Then we just say the empty set. The solution set would be the empty set in that case.